Okay. Hello, everybody. Yeah. As Oliver just said, my name's Tim Fox. Just say a few brief words about myself. I'm employed by Red Hat. Been there for quite a while, although I kind of took a bit of time out, went to Spring Source for a while, and back at Red Hat again. Like Martin, I've been involved in messaging systems for quite a long time, although the kind of messaging systems I'm involved with are less the kind of low latency financial service messaging systems, which arguably is a more niche market, and more the kind of mass market open source messaging systems. So I work exclusively in open source software. I don't do anything else. There's no proprietary stuff at all. For the last 10 years of my career, it's been open source exclusively. Other than Vert.x, other projects I've been involved with, I work with the RabbitMQ team. I'm the creator of the HornetQ messaging system, which is the one inside JBoss application server. That's about to be merged. Who's heard of ActiveMQ? There's another one. Not many people. Okay, surprising. All right. So basically, HornetQ is going to be merged with ActiveMQ, and that's going to become another. So anyway, I've been involved with the three biggest open source messaging systems: RabbitMQ, HornetQ, and ActiveMQ, and various other projects. Anyway, so we're not talking about messaging systems here though today. So unlike Martin's talk before, this is more of a general purpose stuff. So I've kind of moved away from the messaging system stuff more to kind of like how do you build applications, the more kind of API design kind of stuff, and how do you scale applications. So who's actually heard of Vert.x? Okay. And how many people have actually used it so far? Right, okay. Yeah. How many people have heard of reactive application development? Okay, so this is kind of like buzzword at the moment, and a lot of people are claiming to be reactive, which means a lot of different things. But we definitely fit into that kind of mold. Who's heard of Node.js? Okay, so you're in the right kind of area, although we're not Node. I've got to get into that in a minute. Yeah, so Vert.x right now, kind of we have a production release, which is Vert.x 2. But right now, most of the development's going on in Vert.x 3. And we're doing loads and loads of new stuff. We're making Vert.x much more embeddable. We're getting away from this kind of like making everything like a container and making it much more embeddable like a library. And loads of new features and really cool stuff. And I'll talk more about that in this talk. So a lot of this talk's really about, a lot of the features are only available in Vert.x 3, or some of the features are only available in Vert.x 3. Other ones, they're not necessarily available in the current production version. So what is Vert.x? It's quite hard to describe because it's a very general purpose kind of thing. It runs on a JVM. It's a framework. Framework's kind of a dirty word to some people. I think when people kind of say framework's dirty word, they're kind of thinking more of a container, right? So when I say framework, I'm not necessarily talking about a container. Some libraries can be frameworks too, right? So. And certainly in Vert.x 3, it's 100% embeddable. You can use it with whatever you want. We're not saying you have to run it inside a Vert.x container. Okay. Very general purpose. We take a lot of inspiration from. So when I was at Spring Source, I worked with the RabbitMQ team for a while, and RabbitMQ is written in Erlang. Erlang is probably one of the most famous implementations of the actor model, and the functional language as well. So that was definitely a source of inspiration. Another source of inspiration was, and I kind of, when I say inspiration, doesn't mean I think it's done everything right. And actually, one of the reasons for Vert.x existing is because we didn't want to do stuff in exactly that way, and we thought we could do it better, and that's Node.js. So in some ways, you can think of Vert.x as a kind of like polyglot bastard love child of kind of Erlang, OTP, and Node.js on the JVM. Okay. We are polyglot, right? So you can develop your Vert.x applications in multiple languages on the JVM. I'll get to that in a bit as well. Very high performance. Everybody says high performance, right? So, but Vert.x is, objectively, we've been measured. There's been a set of frameworks. So who's heard of Tech and Power frameworks? Tech and Power benchmarks. Okay, so there was a set of benchmarks done by a company, nothing to do with us. And then they did admittedly quite trivial benchmarks, and they pretty much measured everything on the market, just about, in some very simple HTTP style benchmarks. And we're right at the top. Not just JVM stuff, like Node.js stuff, and Ruby stuff, and C stuff, and whatever. So very high performance. But what I would say about performance, people can get a bit obsessed about performance, right? And the reality is, everyone says, oh, I want the framework I use to be the fastest one. But actually, most people don't actually need that. Most people aren't writing low latency financial systems that need microsecond response times. Most people are writing websites and stuff like that. They don't need it, right? So actually, you can go a bit up your own arse when it comes to performance. So I'm kind of stepping away from that. As long as it's good enough, that's good enough for most people. And we won the JAX Innovation Award this year for the most innovative Java technology. Right, so that's kind of introduction of what Vert.x is. I mentioned Polyglot, so we support Java, JavaScript. In Vert.x 3, we use the Nazorn JavaScript engine. Has anyone actually played with that? And it's available in Java 8 right now. Okay, no one's played with that. Okay, a couple of people. So this is kind of really cool. It's a very fast JavaScript engine, much faster than the old Rhino engine. So we use that. We get Ruby, Groovy, Python. It's using Jython. Jython's kind of been a bit kind of stalled for a long time, but so it's probably not the best language to use. But Clojure, Scala. You can actually use PHP with Vert.x as well, and Ceylon, which is the new language from JBoss. So we support a lot of different languages. At the core of Vert.x, a set of asynchronous APIs. So, you know what I mean by asynchronous? So, kind of event-style APIs. So, instead of saying do this now and then blocking, waiting for a response, you say go and do this. Here's a handler. Call me back in some way when the response is ready. So, the core APIs in Vert.x are pretty much all asynchronous. And we've got stuff, and if you used Node.js before, it's a kind of similar idea. So we have kind of a very small set of core APIs, very, quite low-level stuff, like HTTP and TCP, and we have like SSL support. We actually have WebSocket support in there as well. We have asynchronous file system support, and we have kind of DNS, UDP. We have a thing called the event bus, which is a very core feature in Vert.x. And probably the most important feature. And this is actually a distributed messaging system built into Vert.x. And I'll show you some demonstrations of that a bit later on. We also have support for distributed data. We have distributed map support. So you can kind of, on your network, you can have different nodes putting stuff into maps, distributed maps, and getting the data out. Anyway, we'll get to that. So why asynchronous? Why, I just said, the core APIs in Vert.x are asynchronous. So why do we do that? Why don't we have synchronous APIs that you're probably familiar with? Most APIs in the JDK tend to be asynchronous, and most other languages. Arguably, dealing with asynchronous APIs is harder to reason about, harder to debug, harder to test. And there's a certain amount of truth in that. It's not actually, there's quite a lot of myth actually in there as well. So why are we going down this route? Okay. And it's all about scaling with a lot of concurrency. Not all applications actually need a lot of concurrencies, but a lot of modern applications do. So where does that concurrency come from? It may be that you have a lot of messages flying around from different publishers, different subscribers. It might just be maybe you have a lot of connections. Maybe you have maybe you're running a web server and you have a keep alive. Even with most web servers, you have a keep alive time of like 5 or 10 seconds. So at any one time, with a lot of traffic, you can have a lot of connections you need to support. WebSocket server, lots of connections. Again, long-lived connections. Internet of Things, MQTT, again, long-lived connections. So a lot of modern applications characterize having to support a lot of connections. And, connections can introduce a lot of concurrency. And if you're using a kind of a blocking I/O at the connection level, then you're not going to scale because if you have 1 million connections, you need 1 million threads. And even though threads are a lot cheaper than they used to be on modern operating systems, there's still a lot of overhead there. Okay, so it's all about scalability and dealing with a lot of concurrency. So how do you actually write a Vert.x application? Well, you can just embed it. You can just embed, use those core APIs directly in your application if you like, and use your own threading model and do what you want. But we also provide this thing called a vertical, which basically gives you a concurrency model, okay? And we kind of recommend you use this concurrency. We don't say you have to use it, but we recommend you use this concurrency model. It's a very actor-like concurrency model. So the code you write in Vert.x is written in the form of these things called verticles. And verticles are just lumps of code. They're kind of the basic execution unit of Vert.x. And they can be written in any language you like, so Java, JavaScript, Ruby, whatever. Yeah. So, and you can mix and match them in an application. You can have different verticals written in different languages. And an important thing about a vertical, a particular vertical instance is always single-threaded. Well, there is actually an edge case, an advanced case. I won't go into that right now. But you can assume for now they're all single-threaded. And what this gives you as a developer, you don't have to worry about, synchronized and volatile and locking, and lots of race conditions that just don't occur. It's a much nicer way to write your application. So we're moving away from this kind of like multi-threaded concurrency model to more of an actor model. Yeah. So these you can almost kind of we're not strictly an actor model, but you can kind of think of the verticals as a bit like actors, and they communicate with each other by sending messages over the event bus. And you scale by having more instances, but a particular instance of your vertical is always single-threaded. Yeah. So it's kind of like the actor model. Who's heard of the actor model, by the way? Okay, it's kind of popular. You've got like Roland Kuhn was here just now, and he's obviously the ACCA lead. They're obviously another actor model implementation. So I'll show you a vertical in just a minute. You can run these verticals at the command line, or you can like package them up into your, maybe you have a Gradle or Maven build system. You can use all these tools directly with Vert.x. We're not trying to reinvent the wheel. Okay, so let me show you a very simple vertical. So, what's the font size like there? It's probably a bit big, actually. Well, you can see it, so that's all right. So let's have a look at a hello world vertical. So I have a directory here, and I have two files in it, a Java file and a JavaScript file. Let's have a look at the Java one. Now, I've got a feeling this font size might be a bit too big. Oh, wrong one. My shift key doesn't work for some reason. There we go. Yeah, let me just adjust that font size. Edit. It just depends from projector to projector, really. So let's go down a bit to 20. Okay, still overlapping a bit. But anyway, this is a kind of one of the simplest possible verticals you can write. This time in Java. This particular vertical. We use Java 8 in Vert.x 3 exclusively. And all you're doing here, you have a thing, vertical's got a start method, and then inside that we're going to create an HTTP server. And I'll just scroll across a bit. You can't quite see it all on there. But basically we're just creating an HTTP server, and we're setting a response handler on the server, and we're using lambdas for that. How do I scroll across? Let me just change the font size again, so you can actually see it. Right, hopefully this time. Yeah, so we're creating an HTTP server, we're setting a handler on the server, and that handler is going to be called when a request arrives. And it's just a lambda, Java 8 lambda. And then we're just going to put out some static HTML. So it's a very kind of trivial example, right? So let's run that. How do we actually run that? And have you seen this? If you've used Node.js before, you've seen a similar kind of thing, right? So to run it, you can run it on the command line if you like. And then you can do that just by saying Vert.x run. Oh, hang on a second. It's a Java source file, so we have to compile it first, right? Because you can't run Java source files directly. Actually, no, you can run Java source files directly with Vert.x. So we just run it directly. And let's go to our browser. F5. Okay. Hello world from Java is running. Okay. So it's kind of nice feature of Java. You can run. You don't have to go through this whole kind of like build, compile, cycle for prototyping. So if you're kind of knocking stuff together really easy, creating a demo or doing a bit quick prototyping, you can just run Java stuff directly. We obviously support running class files too, so in a bigger application you would typically compile as well or have it as part of a build. But it's good for prototyping and stuff like that. It's kind of a nice feature. So it's all about kind of one of the main things of Vertical, getting away from this kind of complexity of like, we want you to have real power to do stuff directly, run stuff where you want directly without having to go through this complex packaging. Okay, let's take a look at the JavaScript one. No. Actually learn to type. And this is the same thing written in JavaScript, a bit less verbose. Again, if you've used Node.js before, it's kind of similar, right? So you're creating a server and you're setting a request handler. We can run that too. So when we run verticles directly on the command line, that's called raw verticles. We call them raw verticles. Okay, 5, there we go. Right, so that's kind of a hello world thing. I mentioned before, we have this thing called the event bus in Vert.x. And the event bus, so a little vertical like that by itself is not much use. And a real application is going to be composed of many, many different verticals doing different things. Usually doing one thing and doing one thing well. It's kind of the microservices model, really. Okay, so you can kind of think verticals typically implement your microservices for your application. Yeah, and they then talk to each other either on an event bus or maybe via HTTP, depending what style of microservices you like. Maybe you prefer kind of HTTP microservices, that's fine. But we also provide something called an event bus. So the event bus is the nervous system of Vert.x. And it's really it's basically a transient publish-subscribe messaging system. It's built into Vert.x. And you can send messages, you can send pretty much, it's very, very simple. The messages you actually send, there's no complicated kind of message format. You can send just a primitive type or a string or more complex objects if you want. One thing we kind of recommend for most interactions is to send JSON. And the reason for that is JSON's really well understood by all the different languages. It's really easy to create JSON. It's really easy to to parse it, understand it. If we were sending some sort of serialized Java object to a Ruby vertical, it's going to go, what the fuck? What do I do with this? Right? It's going to be very hard for it to understand. So that's why we kind of say JSON. Although it's not a strict rule, you can use whatever you want. Maybe in an application you don't have any Ruby verticals. Maybe it's all Java, in which case you can send whatever you want. So the event bus, inside a particular JVM instance, you have many different vertices running, and you use the event bus to communicate. But it actually, like I mentioned before, it's actually a distributed messaging system, so it actually joins together multiple Vert.x instances running on the same network. And they'll discover each other and form this kind of like big distributed peer-to-peer event bus. There's no master server. It's not like kind of your typical JMS server or something where you've got kind of like a master server you start up and everybody connects to it and sends stuff. So where are we going here? We're basically going towards a more microservices model for application development. We're moving away from this kind of like application server style. So there's no kind of like monolithic application server where you deploy verticals into. You just run them wherever you want. Yeah, and actually you can run them without even having Vert.x installed, and I'll get to that in a minute. And you have these different parts of your application communicating over the event bus to form your application. So if you had a large application, you can decompose that into different languages. Maybe you have different teams who want to do different parts of the application. Maybe you've got like a web team who wants to use JavaScript because of their skill set. Maybe you have like a back-end team who wants to use Java or Scala or something. They can do that, yeah? And they can be loosely coupled, living on different parts of your network, talking to each other. So no application server. And we take the event bus a step further still. Not only can you use the event bus to join together these services on your own network, we can extend that into the browser too. So you can use the same API or very similar API inside your browser in client-side JavaScript to interact on the event bus as it would do on the server side. So now you have this kind of like big, address space, which, well, it's actually a completely flat address space, which encompasses, your stuff in your server, stuff in your client, and it can all talk to each other in exactly the same way. So this makes it really easy to do this whole kind of like this whole generation of so-called real-time web applications. So kind of pushing stuff to browsers, and we find a lot of people are using Vert.x in the gaming industry, for example, a lot kind of like mobile games, that kind of stuff. It's proven very popular for that kind of thing. We don't force you to use the event bus. I know right now, for instance, HTTP REST microservices are very popular, stuff like Drop Wizard, and you can also use Vert.x in that way. So especially in Vert.x 3, we're bringing a lot of really cool REST support in. We can already do REST microservices in Vert.x, but Vert.x 3, it's going to be a lot easier. So this is kind of interesting thing about Vert.x. We're very unopinionated. We don't say this is how you write web application. It's a toolkit. You can use it in 1,000 different ways. Yeah, and it supports. It's kind of like Node.js in that respect. Node.js itself doesn't say this is how you write a web application. That's kind of done by the modules, the npm modules that sit on top of Node.js, right? And it's similar to Vert.x. The core of Vert.x is very unopinionated. So let me show you the event bus. Okay, so let me shut down that one. So we're in, let's move to a different directory called event bus. I have a very simple example here. I have, let's take a look at receiver.js. Again, another raw vertical. So let me actually use less there. Might be a bit easier to view. Okay, so this vertical is very trivial. It's basically doing the subscribe part of publish-subscribe messaging. Okay, it's registering a handler on the event bus against an address called newsfeed. It's just a string. It could be anything. And whenever it receives data on that address, it's just going to log it out to the console. So whenever it receives a message, it's going to log it out. Okay, so let's run that. Vert.x run receive.js. Now this time we're going to add a switch called cluster. And this tells Vert.x when it starts up, because obviously when I run it in the command line, they're all running in their own JVM. Yeah. This tells Vert.x, the cluster switch tells Vert.x, look, when you start up, look out for any other vertexes that might appear on the network, and if they do, then form a cluster with them. Okay. So it takes a few seconds to, there we go, it's starting now, it's running now. So let's go to another console. Where are we? PWE. And we have a vertical sender.java, this time written in Java, obviously. And this is going to do the publish part of publish-subscribe messaging. And what it's going to do, we're setting a timer that's going to fire every 1,000 milliseconds, every second. And when it does, it's just going to send that message to that same address. Okay? Let's run that. Minus cluster. All right, so and going back to the other console, you can see the other one's picked it up, and that would work wherever it is on the network. Okay, so let's make it a bit more interesting. Let's go to another console, and oh, where am I? PWG. Okay. Let's push that into the browser too. So, in order to push it into the browser, we need to serve a page to the browser, so we need a web server. So we've got a web server written also in Vert.x called bridge-server.js. And actually only the top part of it is the web server. It's very simple to write a web server in Vert.x. If it's not obvious to you what's going on there, I'll just step through it very quickly. We're creating an HTTP server, and then we're setting this request handler on it again. And when we get a request in, we're just going to look at the path of that request. If it's for the root, we're going to serve index.html. Otherwise, we're just going to serve whatever has been asked for. Don't run that in production. There's an obvious security problem there. Okay, I think some of you will have spotted that already. But it's just kind of for demo purposes, right? Now, the bit at the bottom says create a sock.js, but this is kind of the magic. I'm not going to go into that at the moment because I haven't got enough time. There's a lot of features to get through in this presentation. This kind of does the bridging between the event bus, the client-side event bus, and the server-side event bus. So let's run that. So we go Vert.x run. Oh, before we run, actually, let me show you the index.html page we're going to serve. Very trivial example. It's just basically a blank page that's got a bit of JavaScript in it. And the JavaScript opens a connection to the event bus. And then when it's open, we are registering a handler on the event bus, and we're just kind of, doing the same as we did on the server, basically. And then we've got a little bit of jQuery. We're just going to output what we get to the actual page. It's as you can see, I'm a server-side developer, not a client-side developer, so it's very unpretty. Okay. So let's run that. Bridge server. Oh, I forgot the cluster switch, so I have to run it again with the cluster switch. Because all these three parts, they could be running anywhere in a network. They don't have to be in the same place. Okay. Right. Let's go back to our browser, F5. And as you can see, the browser's picked up that same sender. So it's all working on the same event bus, right? So this is kind of a nice feature of Vert.x. Okay, so yeah, I mentioned how to, you've seen already how to run verticles, what I call raw verticals, that can be run on the command line. But for many applications, you don't want to do it that way. Maybe you're kind of more used to the Java, Maven build process, or you have a Gradle build, and you want to package stuff up into jars, and do the kind of like standard Maven kind of thing, and push stuff to Maven repository. You can do all that with Vert.x too. You don't have to do everything like I just said. It works very well with the standard Maven builds and standard Gradle builds. Okay. And Vert.x is completely embeddable as well. You can embed it in your own applications. Say you've got an existing application, you can just embed it and use the parts you want. Okay, so we're not kind of preaching. If you don't want to, we're not saying this is like the container you have to run everything inside. Okay. Okay. Oh yeah, let me just show you an example of a Maven project that's using Vert.x, Vert.x 3, just so you can see how simple it is. Oh, my refresher's gone a bit weird there. Let me just... Okay, IntelliJ, why are you doing that? For some reason the refresher's gone all weird on that. What is it doing? Let me just open that project again. That's very weird. Tell you what, let me restart IntelliJ. Yeah, so you can basically have, what I'm going to show you in a minute, it's basically who's used Maven here before? Who regularly uses Maven as part of your standard build process? Yeah, probably most people, right? So what I'll show you here is just a standard Maven project, nothing, just very vanilla project, and shows you how easy it is to use Vert.x in that way as well. That's a completely different project. It's just opened. So let me just, is it this one? Yeah. Yeah, so I've got a, it's actually the same, that same vertical I just showed you in the command line, but this time it's in, part of a Maven build, saying hello world. And the pom.xml is, very, very vanilla, basically, just including the Vert.x dependency, just setting the compiler to 1.8. And then a little bit at the end here, I'm going to show you in a minute. What we're going to do, we're going to build it into a fat jar. Who's used to the idea of having a fat executable jar? It's kind of fashionable at the moment. So the idea here is you're going to compile everything into one jar and just deploy it, with all the dependencies, including the Vert.x dependencies inside the jar. So you can copy that jar to any server with a JDK in it and just run it. Yeah. So you can have your microservice all packaged up into one little unit and then just copy it wherever you want. And we use the Maven shade jar for doing that. It's kind of a common thing. Right, so let me show you that. So let's shut down these servers here. Yeah, so I'm in the right directory. So let me just run it. So I'm going to just go Maven install, create the, package it up, and actually install it into the local repository. Now, if we actually look in the target directory, you'll see we've got a example project fat jar. So this is the fat executable jar. And we can just run it with java -jar. I'm in the wrong directory. So fat jar. Okay, go back to our browser, F5. So it's working, same example from before, but that's all packaged up. So what I'm demonstrating there is we're not trying to reinvent the wheel when you've already got your own build process at your company. And you can put Vert.x components can be pushed into any Maven repository and resolved like that. In Vert.x 3, we also do a very cool thing. You can actually resolve Maven dependencies at runtime if you want as well. But I haven't got time to go into that. All right, so how am I doing for time, actually? Halfway through. Vert.x also has high availability built in, HA support. So you can run your services. So you say you've got you want redundant services on the server side, so you can run your microservices on the server side, and if one of them fails, another Vert.x node can take over responsibility for that failed service, and that's built into Vert.x. We support we basically detect network partitions using a quorum approach. I'm sure most of you are familiar with that. Who's heard of the quorum approach? Okay, so you basically just start up a number of nodes, and you say, I don't want the network to continue functioning unless there's a certain number of nodes still alive. And if they can't see that number of nodes, then it automatically shut down. Okay. I don't think I actually have an HA demo I could show you, but I don't think I'm going to have time. If I do that, I probably won't have time to show you the rest of the presentation, so I'm going to miss that today. But like most things in Vert.x, the HA is really simple to use. You're not editing complex XML files. The way you enable HA in Vert.x, you just put HA switch on the command line, that's it. Right, so when you let Vert.x run, blah, blah, minus HA. I mean, there are some more advanced settings you can provide, but again, we're not doing that via XML config. Okay. All right, so one interesting feature in Vert.x 3 is basically solving a problem we had in Vert.x 2 about keeping all our APIs up to date. So in Vert.x 2, we support all these, like I mentioned before, we support all these different languages. And we have like a core Java API, and then we have kind of like a version of that API for each of these languages. And as you can imagine, keeping that all up to date is quite a pain. So every time we add something or change something in the Java, we need to update the equivalent or add the equivalent in the JavaScript, and the Ruby, and the Groovy, and the Clojure, and the Python, blah, blah, blah. And add all the tests and everything, right? So it's it's proved to be quite hard to manage, and it's been very time consuming, and it's meant that it's really slowed us down in innovating those APIs. And also we have a very small team. Although we have a good community as well, even so, there's a lot of work to do that. So we thought in Vert.x 3, we need to solve that problem. And the way we're doing it in Vert.x 3, instead of manually maintaining those other language APIs, we're generating them now from the Java API. So all we have to maintain now is the Java API, and everything else gets generated, including the documentation. Yeah. And it's proved to be quite a difficult job. When we went into that, a lot of people said, well, that's not going to work. How are you going to create idiomatic other language APIs? So that the key isn't being idiomatic, because anyone can do code gen, right? But making that actually look like an API that somebody would actually want to use in Ruby or JavaScript is much more difficult. And the way we attacked that was by putting constraints on the Java API. Just generating idiomatic JavaScript, for example, from any Java API would be too hard of a task to do. So we said our Java APIs there's a subset of things you can do in those APIs. So we made the problem more tractable by doing that. So we have a set of constraints on our Java APIs, which makes it a lot easier to do. And we have kind of like so when we, as part of our build, we kind of check we have effectively an annotation process which checks all the Java APIs, and it basically won't compile it if you're doing something you're not allowed to do in the core. Anyway, so we use to actually generate it, we use MVEL templates. It's kind of implementation detail, but it works pretty well. And so far we've done Vert.x 3 is kind of like, we're not there yet, but we've already done JavaScript, Groovy, Salon, and we're basically starting the Scala one at the moment as well. Another thing we learned in Vert.x 2 is all about, who's heard of callback hell? Okay, the pyramid of doom, right? Who kind of works day to day with asynchronous APIs? Okay, and how do you compose those APIs? Sorry? Okay. So it depends on which language you're using, different approaches people use, and there are various different approaches. In the Scala world, and you have So yeah, one big criticism of using raw callback-based APIs is it's quite hard to, for simple things it's simple, but as soon as you say have multiple different streams of data and you want to compose them in more complicated ways, then it starts to become a difficult problem to solve, and it becomes very error-prone. How do you deal with errors and all that kind of stuff as well? there are different ways of mitigating that. Some people, there are various promises libraries that allow you to compose promises in different ways. There's another library called Rx Java. Who's heard of Rx Java? Okay. So Rx Java is based on the original Rx technology from Microsoft, and it's kind of like a sort of a port of that to the Java world. Okay. And what the idea is, it's kind of like promises, but promises generally have one value. They're either the result happens and they're finished, right? But with Rx, it's streams of values. Okay. That's kind of the main limitation with a promise-based approach. It's okay with single value events, single shot events, but it's not much good for streams. So with Vert.x 3, we have a set of libraries you can, an API that allows you to automatically convert the callback-based API into an Rxified API. So anything in Vert.x 3, if you wish, you can then use Rx with it. So you can, say, compose everything. So Rx also provides a set of kind of like functional-like operations that you can apply to the data, like map and flat map, and all those kind of things that you're probably familiar with if you've done any functional stuff. So it's a really nice way of mitigating against that callback hell. Again, Vert.x is unopinionated. This is just one thing you could use. Not everybody uses this or will use this. Other people use different techniques. It's up to you. We're not preaching about it, but we do provide it, and we think it's going to be very useful for more complex applications. Another feature, new feature in Vert.x 3 is what I call distributed data support. So what we provide in Vert.x 3 is ability. Who's used like distributed maps before? Okay, who's heard things like Oracle Coherence, Infinispan, blah, there are various different projects out there that do that kind of thing. So the idea is you can kind of put stuff. You have different nodes in the network. You can put stuff into like a distributed map, and then you can get it out again in different nodes. So we have this support in Vert.x 3. Okay, it's kind of useful for, maybe you have some sort of session state in your application. You want it to survive failure. So you'll set your service, for example, could put some state into a distributed map. When it fails, the other one comes up with the HA. You can get that state out again. We also provide, as well as map, we have an asynchronous lock. So it's quite common in distributed systems to want to do something, but only do it in one place or only do it once. And that's kind of a fairly hard problem to solve in a distributed system. How do you actually guarantee that only one thing's doing that? So to solve that, we provide a very simple API. So you can basically get out an asynchronous lock. So by asynchronous means it doesn't block. You're not sort of saying block until, you're not blocking a thread until you get the lock, and you're not holding that thread until you finish with the lock. You're just saying, get me a lock, and then you go off and do something else. Sometime later, it comes back with the lock for you when it's ready, when it's available. You then do your stuff, and while you're doing your stuff, nobody else can get that lock. And then when you finish, you just release it. Okay, so asynchronous lock, 100% non-blocking, like everything in Vert.x. And we have another thing that's also very useful in many distributed applications, the distributed counter functionality. Again, it's kind of tricky, fiddly problem to solve usually if you're doing it from first principles. How do you, have a counter that you can atomically increment across a cluster? We provide that stuff. Again, asynchronous as well, non-blocking, all non-blocking. Another thing in Vert.x 3, we have management support. So we have we use the CodeHail metrics, which is now part of DropWizard metrics, basically. It's kind of renamed, but so we use that internally. Again, it's an optional add-on to Vert.x. You don't have to use it if you don't want to, but if you do, then basically the Vert.x core objects produce various different events, like the HTTP server will produce events about how many requests per second, all this kind of stuff. And you can expose that via JMX. And we're also going to allow you to expose it via the event bus. So you can have a listener on the event bus anywhere on the network, just sort of tuning into those events, management events, and getting data. So where are we actually, where are we going with this? So with Vert.x 3, it's all about, we're trying to build this like official stack. We're trying to build a end-to-end asynchronous stack of stuff that you can use that you kind of want it's very commonly wanted in a lot of different applications. So like I said before, the Vert.x core itself is a bit low level, and you can't just use the core in most applications. You probably want database access, you put email, you want maybe integration with a messaging system, distributed data, I already mentioned. Maybe you're doing IoT stuff, you want MQTT, CoAP, whatever. You want auth. Another classic thing you want is auth, right? Pretty much every app needs auth. So as well as the core Vert.x, we are basically producing the set of components to sit on top of Vert.x that, kind of Lego bricks that allow you to plug these things together and make real 100% asynchronous applications. We also have a very active community in Vert.x, so a lot of stuff is we have a lot of components written by the community too, certainly in Vert.x 2, and we hope the same continues with Vert.x 3. But the idea of the official stack is we're kind of giving the stamp of QA approval, because certainly in the Node.js world, you have thousands of components in NPM, but how many of those do you really trust to use in production? It's a big problem in the Node.js world. Actually, making sure the quality is up to scratch. Yeah, and also, stuff about loads more stuff to do with REST microservices in Vert.x 3. So we're basically, going very strongly in that direction as well. But again, non-opinionated. So if you want to use the event bus, that's fine too. Okay. So what's it all about? So it's all about, we're moving away from this kind of application server model of development more to a microservices style model. Microservices is kind of means so many different things to different people. To a lot of people, it means HTTP microservices, but that's not the only kind of microservice. You can have event bus style microservices, so instead of interacting with HTTP, they interact in the event bus. We don't preach about that. You can do all those different styles if you want. You could have a MQTT microservice if you wanted, or any other, or maybe just a TCP one. Okay. But the architectural style is you split your application into bits, components that do one thing and one thing only. Those are the microservices. I don't care if they interact on HTTP or event bus, MQTT, whatever. That's up to you. Yeah. And your own preferences. But we're moving away from this application server model. That's the key thing to take home. Polyglot, we're not preaching about the language. We're not saying, one language is better than any other language. It depends. Everyone has a different opinion. So we try and support a lot of different languages. So you can use, depending on your personal preferences, depending on the job at hand, what are you actually building? What's the appropriate tool? And also depending on the skill set of your teams. You're not having to tell everybody, retrain everybody to JavaScript or Scala or whatever. And like I mentioned before, so we want to produce this library of Lego bricks for this official stack so you can put everything together. And Vert.x right now, we're getting a lot, my employer, Red Hat, it's putting a lot of investment into Vert.x. It's kind of a strategic project for Red Hat. So we kind of see this as the future, in some ways, the future of the app server. What I would say, it's not a Red Hat project. Vert.x is actually an Eclipse project in terms of IP. Eclipse control the trademark, all that stuff. And that's because of the history of Vert.x. I started it when I was at VMware, and there's kind of like a legal battle and stuff, and we ended up in, anyway. But the key point there I was trying to make was it's not owned by Red Hat. It's not completely, Red Hat doesn't say you do it this way, okay? Red Hat don't control the direction of the project, although they do invest in it. And so we're 100%, everything's open source, everything's in the open. We're not developing anything behind closed doors, everything's in the open. So if you're interested in getting involved, please get involved. We're on GitHub. I haven't actually looked at the statistics for a while, but we were at one point we were one of the most popular Java projects on GitHub, in the whole of GitHub. But if we're doing a lot of cool stuff now. Actually, with Vert.x 3, we're probably doing. I'm actually more excited now than at any time during the development of Vert.x with the cool stuff we're doing. We think it's going to be really big and take Vert.x to the next level. So if you want to get involved with that, there's loads of stuff to do, and just come to our Google group or send me an email or whatever. Or IRC, we have an IRC channel on freenode.net, and basically the whole team hangs out there. And that's basically what I just said, isn't it? yeah, so freenode.net Vert.x IC channel. So if you're interested in getting involved, please do. And that's it. Thanks, thank you, everyone.
Thank you. So I will start the Q&A session with the questions asked you over that. First question was already answered in your talk. Second question, how does a vertical compare with an actor? Does it also provide concepts like parent-child and supervision hierarchies?
Yeah, good question. So the question is, so in the actor model, you basically have this like the concept of supervision. You delegate the restarting and stuff to something other than the actual actor. So in Vert.x 3, we are introducing a similar idea. We don't have it right now in Vert.x 2, but we're going to introduce a similar idea to a supervision tree in Vert.x 3. But we don't have that right now.
Okay, so the next question, how could... Speak a little louder, please. Okay, sorry. The next question is, how could I interface Vert.x with Go, language Go?
So the question is, is it possible to have interop between Vert.x and Go? I have no idea, sorry. But actually, probably what you could do, I mean, obviously Go is not JVM, but what you could do is, what you can do with Vert.x with any non-JVM stuff, you can pretty much bridge into it just by opening a if you have WebSocket support, I imagine Go probably has WebSocket client support. Most things do. So you could create a WebSocket into Vert.x and then basically interact on the event bus from that. That would be possible, I imagine, assuming Go has client-side WebSocket support. I'd say a few more words on that. In Vert.x 3, we're going to try and... this idea of interoperability with non-JVM stuff is quite important. So we're going to have interop, say, of Node.js and you know, MRI, Ruby environments and other non-JVM stuff. So we're thinking of exposing some sort of wire protocol, of a kind of simple socket-based protocol that you can actually connect up into Vert.x with. So that's something we're thinking about at the moment. We're not quite sure how it's going to go. But
Okay. Are there any other questions? How do you handle synchron I/O like JDBC?
so the question is, how do you handle synchronous stuff like JDBC? So JDBC is inherently synchronous. And obviously, we can't change the JDBC API, so how do we deal with that? It's actually a general problem. A lot of APIs, traditional APIs in Java world, are synchronous. So we have a concept of a worker to deal with that. So if you're on a standard vertical, you're on the event loop, you must not block that event loop, because if you do that, then your system becomes unresponsive, because you can't do anything else while it's blocked. So if you want to call a blocking API, what we do is we have a thing called a worker vertical. You put that blocking code in the worker vertical, and then you run it as a worker vertical. What that means is it runs, instead of running on the event loop, it runs on a thread from a thread pool. Yeah, so you can block that, and then it communicates back to the other vertical, again, by messaging. Yeah. But sorry, async JDBC would be, I would love to have async JDBC, and I've been asking for it for ages, but I'm not holding my breath. Question is, what parts, all these different features, do we, what do we use stuff internally to actually implement that? Yeah, so we use, for a lot of the I/O, especially the socket I/O, we use Netty. The file system stuff we do directly with the JDK API. The event bus, the discovery part of the event bus, so the kind of how do nodes see each other, that we delegate to something called the cluster manager, which is like an SPI. Yeah, and we have a default implementation of that SPI which uses Hazelcast by default. But you could basically create your own implementation that uses something different. And we already have people we've got a Zookeeper implementation as well. I think it's like 2 or 3 different implementations, but the default one in the distribution is Hazelcast. What else? Yes, distributed maps, again, that delegates to the cluster manager. So in the default case, that uses Hazelcast. But you could say plug in InfiniSpan or something for that if you wanted. Or actually, there's going to be another implementation of that that uses JGroups. There's going to be another implementation. So you have to choose basically which one you want. Yeah. Yeah. So we're not re-implementing every single thing from scratch, because that'd be a lot of work. Yeah. When will version 3 be available? Good question. There's a lot to do. I'm hoping, it's not a promise, I'm hoping like the beginning of next year at some point, maybe the first quarter of next year, realistically. We have a lot to do. I mean, the main thing is really just building out those components that, you know, database support and all that kind of stuff. A lot of stuff already exists. We have to kind of port it to Vert.x 3 and do all the documentation and all that stuff. It kind of takes time.
There was another question.
Yeah, good question. So are we supporting the Reactive Streams API? So the Reactive Streams API, there's a cross-company effort that's been led by TypeSafe, but it also includes Red Hat, various other groups, Pivotal, and various other companies. The idea is to provide basically a way to interoperate between different reactive systems and provide, be able to push back back pressure between the systems, which is very important when you're dealing with asynchronous systems. Now we're already signed up to that. We're one of the people involved with that. We already have a reactive streams implementation for Vert.x 3. You can already use that. Yeah. Thank you.